Welcome to CSIR Solutions. The question chosen is from June 2012, which appeared for 4 marks. What are the changes that occur in hemerythrin when dioxygen binds to it? Is one iron getting oxidized or both iron getting oxidized? Is dioxygen binding only to one iron atom with a hydrogen bond? Or is dioxygen binding to both the iron atoms along with a hydrogen bond? So the options given are in combination. This is a understanding question, so where we need to know the structure of the deoxy as well as oxyhemerythrin. So just let us discuss the structure. Hemerythrin, as we are aware of, it is a bimetallic iron center. It is a non-heme iron protein. So just let me start with two irons. These two irons are bridged by a hydroxo. They are also bridged by a couple of endogenous bridges, one from aspartate and another one from glutamate. So I am abbreviating it as GLU glutamate. Since there are two irons, to discriminate between these two iron centers, let me label them as iron A and iron B. Iron A is coordinated to 3 nitrogens of histidine along with 3 bridges. It is coordinated to 3 nitrogens of histidine. This histidine nitrogen is a part of protein chain that contain amino acids. We can number these amino acids 101. 73 amino acids are present in the chain, and whereas for this there are 77 amino acids. Getting to iron B, this is coordinated to 2 nitrogen histidines, which is a part of a protein chain having amino acids. Number is 54 and this is bound to 25. So we can find out difference where iron A has a coordination number of 6, whereas iron B has a coordination number of only 5. So we can say that iron A is coordinatively saturated, whereas iron B is coordinatively unsaturated. Since this is unsaturated, the dioxygen can come and bind to iron B. So here we are getting one of the options. Dioxygen can bind only to one of the iron atoms. There is also a possibility of hydrogen bond. So let us draw dioxygen. Now this has bound to iron B. Once it is bound, there is a hydrogen bonding. So this hydrogen bonding becomes so stronger that this hydrogen will be retained by this peroxide. Let me draw the next structure. This is a oxidized form, and the distance between the two iron centers will reduce because we find that both irons get oxidized. Attractive power will be more, therefore the distance between the two irons will be less. In this case, the distance between the two irons will be more. Now this become a hydroperoxide. Still there exists a hydrogen bonding. This was a hydroxo bridge in the deoxy form. Once it got oxygenated, where the dioxygen is converting into a peroxo form, this peroxo oxygen will take up the hydrogen and the hydroxo bridge is converting into an oxo bridge. Peroxide is converting into hydroperoxide, but hydrogen bonding is still continuing. The oxidation state for both the irons in the deoxy state was found to be +2, but as one of the irons bound with the dioxygen, slowly the +2 oxidation state will be converted into +3. So directly one iron is involved in oxidation state increase where it is attached to a dioxygen. The second iron is not directly bound to the dioxygen, but still it is getting oxidized, and the possibility is from a oxo bridge. So the electron transfer is possibly moving through a oxo bridge. Here we are also getting another option. both irons are getting oxidized. Only one of the iron atoms is binding to the dioxygen along with the hydrogen bonding. Now let us look at the options. Both iron atoms are oxidized. Iron 2 is converting into iron 3. This is also converting into iron 3. So option B is correct. Also come to see, dioxygen binds to one iron atom. Both the iron atom. No, it is binding only to one iron atom. Is there any hydrogen bonding? Yes, there is a hydrogen bonding. So C is also correct. Now we have to check for a combination of B and C. B and C is a combination with A. This is B and D, A and D, and A and C. So the answer must be a combination of both irons getting oxidized and only one iron atom is binding to dioxygen along with a hydrogen bond. So this is the option. Thank you.